here. So this is my complete slab designing steps as well as the calculation part, which is comes under the manual method as per IS 456-2000 code. Okay, so if you remember this particular 7 pages, you can able to design any one of the slab as per the standards. Okay, so before going to designing of any kind of the RCC slab, just we have to follow these 7 steps. Okay, so these are the 7 steps we need to follow as per the calculation part, which is comes under the IS standard system. Okay, first step is to calculate the ratio of the length of the long span to length of the short span. Okay, and the second step is effective depth, and third step is loads calculation, and fourth step is bending moment calculation, and fifth one is check for the depth, and the sixth one is area of the steel, and last one is we need to check for the deflection also. Okay, so these are the 7 steps we need to follow, and we need to keep IS 456-2000 codal provision standard for the requirement of the calculations. Okay, so first step here in this case, just I am assuming for the slab designing. So here I am taking the dimensions of the slab is approximately 3.01 meter cross 3.70 meter. Okay, so just I am taking the grade of the concrete is M20 grade concrete, and grade of the steel is 500. So here in this case, Ly is the length of the slab in y direction condition, which is of long length, which is of 3.7, and Lx is the shorter length, which is comes under 3.01. Okay, so if you calculate the Ly by Lx, which is nothing but the length of the longitudinal long span to length of the short span, it will get the factor is 3.7 divided by 3.01, which is approximately equal to 1.23 value. This is less than 2. Basically, if you have the value of the length of the long span to length of the short span is greater than 2, we will consider as one-way slab. So here in this case, the length of the long span to length of the short span ratio is less than 2. So that's why we need to consider as two-way slab system. Okay, so the slab will be comes under the two-way slab system. We need to follow the two-way slab system procedure. Okay, so second step is to calculate the effective depth. So before calculating the effective depth of the any kind of the slab, initially we need to assume the thickness of the slab. So here in this case, just I was assuming the thickness of the slab is approximately 115 mm. Okay, so effective depth is approximately equal to assumed thickness minus cover plus diameter of the reinforcement bar divided by 2. This is the formula we will consider from the IS codal provision standard system. Okay, so if you substitute the particular values, so here in this case, just I am assuming the cover will be consisting of 15 mm, and as well as the diameter of the bar is 10 mm. Okay, so 115 minus 15 plus 10 by 2, which is comes under the value is 95 mm here. Okay, so this is the second step. Third step is to calculate the loads. So here in this case, just I was taking the dead load of the slab, which is comes under the self weight of the slab, which is approximately equal to 0.115 multiplied by 25. So here in this case, 0.115 is nothing but the thickness of the slab we are taking assumption, and 25 is the unit weight of the concrete, RCC concrete, unit weight of the concrete we are considered as 25. Okay, so if you multiply this particular value, we will get the values approximately 2.875 kilonewton per meter square. Okay, so second step is to assume the value of the floor finishing load, which is comes under the marbles and tiles which is laid on the particular slab. So here in this case, just I am taking the value of the marbles and tiles, which is comes under the 100 mm thickness, maximum thickness. So if you multiply that respected 0.1 multiplied by unit weight of the mortar 20, then it will get the value is 1 kilonewton per meter square. Okay, so this time assuming the live load will be comes under 2 kilonewton per meter square for this particular area of the slab. Okay, so and this next one is total load calculation. So total load is the summation of this particular dead load of the self weight of the slab and floor finishing load as well as the live load. So which is comes under the 5.875 kilonewton per meter square. So before calculating any kind of the reinforcement value that will be comes under the slab section, we have to consider the factor load. Okay, because of the safety of the particular structure, we will consider extra 50% of the load in the designing section. Okay, so that's why just I am considering factor load is 1.5 times of 5.875, which is comes under the 8.8125 kilonewton per meter square here. Okay, so the next one is to calculation of the bending moment value. Okay, so before calculating the bending moment values, we need to take the coefficient values, which is comes under the alpha x value and alpha y value for the respected negative direction as well as the positive direction for the particular slab section. So the alpha x values and alpha y value will be available in the code book IS 456 2000 code, which is of page number 91. Okay, so here in this case, just I am opening my IS 456 2000 codal provision standard system. Just I am opening my page number 91. The table will be available in the page number 91. Bending moment coefficients for rectangular panels supported on the 4 sides for the provision for the tension at the corners. Okay, the value of the negative as well as the positive moments will be considered from this particular table. Okay, so please see the values which is comes under the shortest span coefficients, which is comes under this for the particular values. Again, it will be available for the respected bending moment coefficient for the slab spanning in 2 direction at right angles, simply supported on the 4 sides. Okay, these are the factors we are considered for this respected particular slab. From the table number 26, I was consider the values of the negative alpha x is 0.06 and coefficient of positive will be 0.045 and long span coefficient negative will be of 0.047 and positive alpha y will be 0.035. Okay, so basically we need to calculate the value of the bending moment. For calculation of the bending moment, we have the formula alpha into W into L square. Okay, basically we are considering in the x direction condition system, that's why we are taken here as alpha x into W into L x square here. Okay, and in y direction condition we have to consider alpha y into W into L square into x. Okay, y, not x here. So bending moment along the shorter span. So here in this case, shorter span will be comes under the negative bending moment. Okay, so negative minus alpha x into W into Lx square. Okay, so here in this case, negative minus will be comes under the 0.06. So we have to substitute this particular value here in this case. And W will be of the load, factor load we are calculated over this particular step number 1. We are available with value of 8.125 value here. Okay, so here in this case, I am substituting this particular value. So Lx is the length of the particular slab which is comes under the shorter span. So here in this case, in the input which are given the values 3.01 here. Okay, so we have to substitute this particular value here so that it can get the value of the moment will be of 4.902 kilonewton meter. In the same process, the positive moment will be comes under the plus sigma x into W into L square. Okay, in x direction. So if you substitute that particular value, so that it can get the bending moment value will be of 3.682 kilonewton meter. Okay, again in the same process, in the y direction we have the formula minus alpha x into W into Lx square, which is comes under this particular 0.047 into 8.8125 into 3.01 square, so that we can get the value of bending moment will be of 3.752 kilonewton meter. In the same process, positive will be alpha y into W into Lx square, which is approximately equal to 0.035 into 8.8125 into 3.01 square, which is comes under the moment is this particular 2.794 kilonewton meter. Okay, so here in this case, the y direction moment is also considered in Lx square only, not Ly. So after calculating this particular moment, we need to check for the depth. Okay, this is the next step which is comes under the slab calculation process. Okay, so basically we have the formula which is related to the mu equals to 0.138 into sigma ck into b into d square. Okay, so if you substitute this, but if you modify this particular formula, we will get the formula is d square equals to mu divided by 0.138 into fck into b. Okay, if you need the value of the d value, depth, so we need to give the square root for this particular factor. Okay, so again in the same process, if you substitute this particular values, so from the moment value we need to consider the maximum moment which is comes under the both negative or positive in x direction y direction condition system. So here in this case, the maximum moment will be comes under the negative x direction case, which is of 4.902 kilonewton meter. Okay, so here in this case, just I am substituting this particular value. So here I am multiplying this particular value to 10 power 6 in order to get the value of the mm for the particular depth. So just I am dividing this particular value with 0.138 into 20 into 1000, so that it can get the value will be of approximately 42.14 mm. Okay, so assume effective depth will be, just we are assuming that particular effective depth will be of 95 mm. So here in this case, the step number 2 we are calculated the effective depth which is comes under the 95 mm. So that is the assumed effective depth. Okay, from the depth checking value, it is coming greater than value which is comes under the 42.11 mm. Okay, so if you consider the value, any value which is greater than 42.14 mm, it is sufficient for this particular slab. So here in this case we are taking the effective depth which is calculated as per the second step is 95 mm, hence it is safe. Okay, so the next step is to calculation process of the steel. Okay, so basically at the support condition system we have the steel, again at the mid-span system also we have the steel and spacing of the bars for the particular section. Okay, so here in this step which is comes under the design of the reinforcement, which is comes under the shorter span only, which is comes under 3.01 meter length. Okay, so at the support condition we have the formula again AST equals to 0.5. This respected formula is available in the IS 456 2000 codal provision. You can check the formula directly, it is available in the IS 456 2000. So AST equals to 0.5 into sigma ck divided by sigma y into 1 minus square root of 1 minus 4.6 into mu divided by sigma ck into b into d square into b into d. Okay, so if you substitute this particular value 0.5 into 20 divided by 500 into 1 minus square root of 1 minus 4.6 into 4.902 into 10 power 6 divided by this particular 20 into 1000 into 95 square into 1000 into 95, so that it can get the values 122.636 mm square. Okay, at the mid span again if you substitute this particular value for 0.5 into fck into fy divided by 1 minus square root of this particular value, so that it can get the value will be of approximately 0.5 into 20 divided by 500 into 1 minus square root of 1 minus 4.6 into the moment value will be changes here. Okay, so this respected value multiplied by 10 power 6 divided by this particular substitution, so that it can get the values approximately 91.339 mm square here. Okay, the spacing we had to provide it for this respected AST requirement. Okay, so if you consider the spacing value, we are already know that formula which is related to the pi by 4 into d square divided by AST multiplied by 1000. If you substitute this particular value, we already know that we are assuming that diameter of the bar will be comes under the 10 mm. So if you substitute this particular 10 mm diameter bar here in this case of the diameter, so that it can get the value will be a pi by 4 into 10 power square divided by 122.636 multiplied by 1000, so that it can get the spacing will be approximately equal to 409.667 mm square. Okay, so adopt 20 mm section for the respected particular spacing option. Okay, why? Because we are not considering any kind of this particular higher amount of the spacing for the slab as per the standards which is provided for the IS 456 2000. Again, AST provided will be comes under this particular spacing. Okay, so if you want to calculate the AST provided, then we have to do the reverse calculation for the consideration. Okay, so pi by 4 into d square divided by spacing into multiplied by 1000. So we know that the spacing value as well as this particular diameter of the bar. So if you substitute the value, then it will get the values approximately 392.5 mm square. Okay, so so we have to provide the tension reinforcement which is comes under the 10 mm diameter bar which is placed at a distance of 200 mm center to center distance. This is the shorter span calculation. Again in the same process we have to calculate the longer span calculation, which is same as the process which is provided for the shorter span. So required will be of approximately 0.5 into 20 divided by 5 into 1 minus square root of 1 minus 4.6 into 3.752 into 10 power 6 divided by 20 into 1000 into 95 square into 1000 into 95, so that it can get the value 93.134 mm square at the mid span, which is comes under the moment of 2.794 into 10 power 6. The rest of the values will be same, that is comes under this particular value. We have to consider this particular 93.134 is the moment value for the calculation process. So spacing will be approximately equal to this particular pi by 4 into d square into AST, so which is of 93.134 into 1000, so that it can get the values here again 340 approximately. So but we have to adopt the low value for this particular consideration as per the standards. So here in this case just I am considering 200 mm. So AST provided will be approximately equal to pi by 4 into d square into spacing multiplied by 1000, so that it can get the values approximately 392.5 mm 392.5 mm square for the respected consideration. Okay, So here in this case we have to consider again the tension bar, which is comes under the 10 mm diameter bar, which is placed at a distance of 200 center to center distance. So for the respected shorter span and longer span, the same amount of the reinforcement is getting. So again, after calculating the reinforcement value, we need to check for the deflection. This is the important one. Okay, so deflection will be comes under length of the shortest Lx divided by d provided less than L divided by d maximum. This is the formula we have to follow. Lx by d provided, which is equals to 3010. This is the length of the slab, which is of shorter span divided by effective depth, which is of 95, so that it can get the value 31.684. So L by d maximum, which is equals to modification factor multiplied by 32. Okay, modification value will be calculated according to the formula and according to the graph, which is provided in the page number 38 of IS 456 2000 Codal Provision Standard. So here I am opening my page number 38. Now you can see this is the graph we have to follow for calculation of the modification factor. Fs equals to 0.858 into Fy into area of the cross section steel required by area of the cross section steel provided. Okay, this is the formula. Basically we will consider this particular modification factor from this plot. Okay, so here in this case just I want to calculate the value. So Fs equals to 0.8 into AST required by AST provided. So here in this case, if you substitute this particular value, then it will get Fs equals to 90.610. So PT percentage, okay, which is equals to AST divided by B into D into 1000. So if you substitute the value 122.636 divided by 1000 into 95 into 100, so that it can get the value is 0.13. So L by D in maximum equals to, we had to substitute this particular value. For this particular value of Fs and PT, the value of the modification factor will be get as 2. Okay, so L by D max equals to 2 into 32 value, so that it can get the values approximately 68.4 here. Okay, so L by D provided equals to 31.684 we are get here. Okay, so here in this case the value of the L by D provided is less than L by D max, which is of 64. So in this case the deflection is safe for the particular slab section. Okay, so this is the complete calculation part, which is comes under the RCC slab design by using manual calculation method as per IS 456 2000 Codal Provision Standard System. If you have any queries about this respected video, please try to text me your questions in the below comment box. I will try to give the answer for that respected questions. And if you need this PDF, please text me to my mail, which is available on the About Us page. So you can check my mail and you can text me, so that I will drop you this particular PDF in your mail. Okay, thank you.